Today we are going to solve a problem from magnetic field and electromagnetism. It's for the 12th physics Nelson book. So I like to read the question. A coil 15 centimeter with 100 turns and a current of 20 ampere lies in a horizontal plane. A light flame supports the rectangular conducting wire WX. So I can say this one is the WXYZ. Balanced horizontally at its midpoint in the core of the coil as shown in the figure. The sides WX, YZ, that means WX and YZ are parallel to the axis of the coil. Side XY is length 1.5 centimeter and perpendicular to the axis of the coil. Further, there is a mass is attached with the end of the rectangular element. Now the question is, what current must flow through the rectangular conductor to keep it in horizontal balance? That means this setup looks like a current instrument. Current instrument is something demonstrated a deflecting force of a current carrying element which is placed in a magnetic field. So let us find the magnetic field first. So the magnetic field will be can be calculated by using the formula B equal mu0 n I over L. Mu0 is the permeability constant, which is equal to 4 pi times 10 power 7 Tesla meter per ampere. The next one is N. N is the number of turns. You can see the turns of the solenoid. Solenoid is a type of coil, that's all. Normally made up of copper. So number of turns in the coil. I is the current in ampere. The unit is ampere. L is the length of the element. Length of the solenoid here. So here the L is given to us. Here it is 15 centimeter. So this is not our unit, we have to change it to MKS unit. So MKS unit is meter, so 1 meter is equal to 100 centimeters. So 15 over 100 will be equal to 0.15 meter. The current is also given here, 20 ampere, our unit. No problem, no need to do any change. And number of turns is 100 turns. And this is the constant. Now let us calculate the magnetic field, B. So B will be equal to 4 pi 10 to the power negative 7 times 100 times, and the current is 20 amperes, or the length of the conductor is, length of the solenoid is 0.15. So I can put the unit. So make the space a little more. So it will be Tesla meter per ampere. So we have space now. Times, and the current is, as a turn is 100 turns, times the current is 20 amperes. And this one is length in meters. So here the ampere get cancelled, and the unit meter and meter get cancelled. So our answer will be in Tesla, which is a unit for the magnetic field. Now let us find the value of the magnetic field. So 4 times 3.14 exponential negative 7 times 100. Once again, 4 times 3.14 exponential -7 times 100 times 20 over 0.15 and getting the answer 0.4 -7 100 times 20. So the answer will be 0.01674. I like many numbers so that the students can see the exact answer from the book. So at the last I used to round. Now what happened? This element is having a horizontal axis. Here the horizontal axis has no effect, it do nothing. But only the perpendicular line XY is perpendicular to the magnetic field. So the magnetic field acts downwards. So force due to magnetic field. And here there is a mass available that gives the force due to gravity. So we have to equate. So let us find the force due to magnet by using this formula. Force due to the magnetic field will be equal to BIL sine theta. So B is the magnetic field as it is, so we can write it here. B is the magnetic field. I is the current as it is. L is the length of the conductor. The first question we use the length of the solenoid. Now we have to use the length. Which one is giving the length? Only XY, which is perpendicular to the magnetic field, will give you the, because that is the only thing will give the force. So we have to use the length of XY. What is the length of XY? The length of XY is 1.5 centimeters. So XY equal is not our unit, 1.5 centimeter. So when we are divided by 100, so it will be 0.015. So meters. So B already we calculated, we can use this value 0.016746 times, and the current will be, we have to find the current, let it be I, and the length will be 0.015 and that angle theta. So this is XY and this one is perpendicular to the magnetic field. So perpendicular to the magnetic field means it will be 90. So we have value sine 90, and this one why I told that WXYZ do nothing means they are parallel. So if we find the value, parallel means straight line. So sine 180, we all know that the value of sine 180 will be equal to, you can see from the calculator, it is 0. So nothing, the WX and ZY do nothing. So XY will do something. So that angle is sine 90. We all know that sine 90 is equal to 1. So we can put the theta sine 90. Here, this one gives force due to gravity, and this one gives force due to magnetic field, and these both should be equal. So we all know that the mass is here, so the Fg will be equal to mass times acceleration due to gravity. Fm is equal to BIL sine theta. They both should be equated now. So Fg is equal to mass. The mass is given 1.8 10 to the power negative 1.8 10 to the power negative 2 gram. This is not our unit. We have to change into kilograms. So 1.8 10 to the power negative 2 divided by 10 power 3. So 1.8 10 to the power negative 2, this will go 10 to the power, this will go to the numerator side, it will become negative 5 kilograms. So now we can equate this part 1.8 10 to the power negative 5. We know gravity 9.8 equal to this value 0.016746 times current. We are going to calculate 0.015 times sine 90. Now we have to calculate the value of I. So the I will be equal to, the value of the current will be equal to 1.8 10 to the power negative 5 over, times 9.8 over 0.16746 times 0.015 times sine 90. Sine 90 is 1, we all know that one. Let us see the value. So it's a big calculation. 1.8 exponential negative 5 times 9.8 over 0.16746 times 0.015 times sine 90. So the answer will be equal to this one. Wait a minute. Answer is 1.8 exponential negative 5 times 9.8 over 0. I forgot to miss 1 0 here. It will be 0.016. So 0.016746 times 0.015 times sine 90. So we are getting the answer as 0.7 ampere. So you can check the answer in the book. The exact answer for the current value is 0.78. So have a look here. So this is the current instrument. So I explained already what is current instrument. So I found the magnetic field first without giving the current value. By having our existing current value, I got the magnetic field 0.016746 Tesla. After that I found the magnetic force, which will be influenced by XY. I got the answer as the formula 0.0166746 times I 0.015 sine 90. Then I equate that downward force by gravity, and finally I got the current value 0.7 ampere. This is a very important question. Normally it's a grade 12 Ontario curriculum, Nelson physics, magnetic field and electromagnetism topic, and it's a review question. Question number 13, page number 428. This question is often good for the project, and it is quite difficult for the students to find the solution. So I gave the full solution with the full explanation. I gave the correct answer, and that's all. So please subscribe to my video to see my new videos. Thank you for watching my video. Bye.